welcome to this family event brought to you by the Great Exhibition Road Festival here in London. My name is Sophia. I am a master's student at Imperial College and I study science communication. And today we're going to be talking about green energy. And we've got a scientist coming on and she's going to be telling us a little bit about it. And we've also got a really amazing quiz planned and an activity later on. So just to make sure everyone's feeling super comfortable, make sure you introduce yourself into the chat. Maybe put a little bit about yourself so everyone can get to know each other. And if you're having any issues, just remember to put anything into the comment section. You need to log in with Gmail. So maybe grab an adult to help with that. And as we go on, we just want to hear from you. We want to hear any questions that you have. So feel free to put any comments or questions in the chat and we'll make sure to see and answer them if we can. So without further ado, we're going to be talking about green energy, like I said, but I cannot speak on the topic. So we've got a really amazing researcher that's going to be joining us. So I'm going to introduce Louise. And hello, Louise. And maybe you can introduce yourself a little bit.
Hi, Sophia. Thanks for that introduction. And hi, everyone listening at home. So my name's Louise. I am a researcher here at Imperial. I'm actually doing a PhD just at the beginning of it. And I am researching green energy, which is obviously what we're here to talk about today. I'm really excited to hear any questions you guys have as we're going along. So please feel free to send any questions into the chat and we will do our best to answer them as we go along. And I'm really looking forward to this.
Amazing. So before we get into the technical science, maybe you can tell our audience about, what got you into science? What made you interested in the field in the first place?
So I think my favorite thing about science is it helps explain why. I feel like I was always very curious and I always had these questions, well, why does this happen and why does that happen? And science as a sort of field is all about answering those questions. And I particularly like that it's about doing experiments to find those things out. So when I was young at home, I would do experiments with my parents. We used to make volcanoes out of vinegar and bicarbonate of soda in a mound of flour. That was always a fun one. And then I remember when I got to secondary school and we got to wear lab goggles and use test tubes and it was all really exciting. So and that's what really got me hooked and really excited. I really like the idea that you can have a question about the world, you can plan an experiment, and then you can use the results from that experiment to try and answer your question. And actually the best part about it is not only do you answer your question, but it brings up even more new questions to you. So there's always more things that you can learn and find out. And I think that's just really exciting.
Yeah, it's really like the hands-on aspect of it, which is kind of cool. So you mentioned that you're doing your PhD. So just for our listeners at home, what does it mean to be a researcher?
Sure. So a researcher means that you're trying to find out new things. So no one knows the answers, no one's done it before. And it's up to you really. And that seems a bit daunting and big, but actually it's really exciting. And there's so many people doing lots of different research and you can chat to different people who are working on slightly different things that are related. And then you can kind of work together with other scientists, sometimes from all over the world, working to solve big problems, such as sort of the energy problem that we're here to talk about today.
Oh, I love that. That's like a community that you've developed. That's really cool. And I'm sure everyone watching at home has their own community that they can kind of explore ideas with. So it's really amazing. So now let's get into the science behind it. We talk about green chemistry. That's what you're studying. What is green chemistry and what makes it different than regular chemistry? I've honestly never heard of it.
Sure. So green chemistry is kind of a new term, really. So for anyone listening at home who isn't sure which part of science chemistry is, that's all about molecules, the things that make up our world. And it's quite a broad topic, really. But green chemistry is specifically focused on the challenge of sustainability. So some of you might have heard of this word before. It is quite long. But when something is sustainable, this means that we have enough resources, so things and energy, that not only can we do it now, but we can keep doing it in the future. So things won't run out, or we won't release too many bad things from a process that will prevent us from doing something further down the line. So green chemistry as a whole is quite broad. So it's any process that involves chemistry, making it, thinking about sustainability. But within that green chemistry broader topic, we have green energy, and that's sort of where I sit. And that's research, that's chemistry research, but looking at the problem of energy. How are we going to get our energy in the future? Because it needs to be renewable.
Renewable energy. So I'm not really familiar with renewable energy. Maybe you guys are at home. So maybe put in the chat what you guys think renewable energy is. But I guess to me, that would be like wind energy. What do you think?
Yeah, great suggestion. We'd be keen to hear what anyone else has to say.
Yeah, make sure you put it in the chat, and we want to hear from you what you guys think renewable energy is. Let's see.
Whilst we're waiting for some answers, maybe Sophia, do you have any ideas about where we get lots of our energy from at the moment?
Yeah, I'm not 100% sure. Maybe like solar panels and hydro energy, probably.
Great answers.
Okay, maybe we want to get a few more answers. So maybe is there a clue slide we can bring up? Does anyone have any ideas?
We've got an answer from Olga there. Yeah, great. So solar, wind. Yes, these are brilliant examples of renewables, as shown in this slide as a little clue.
Yeah, solar and wind. That's amazing. Yeah, I don't know. Let's see if this is coming up. Okay, well, that was a great answer. And yeah, if you guys have any ideas that come up to you, maybe put them in the chat as well. But we have a question coming in from the audience, and I'm going to read it out, and maybe Louise, you can answer that. So Isatu says, when the natural sources of renewable energy, for example, solar power and wind, aren't available, what do we do if there's no wind or sun? Where do we get our energy if we don't have those kind of those renewable energy sources available?
Yeah, so this is a fantastic question. So solar and wind are great examples of renewable energy, and the actual sort of definition of renewable means that it doesn't run out. So they're energy sources that will always be there. Linking back to that theme of sustainability, it will be available for future generations. And this is really important because most of our energy so far globally has come from something called fossil fuels. So examples that you guys at home might have heard of are things like the petrol in your cars, but all fossil fuels include oil, coal, and natural gas. And these are made from small plants and animals that died millions and millions of years ago and have been compacted over time. So they're really energy rich, but it takes millions of years to make them. And we've been using them up way faster than new ones can be made. And we'll come back to other problems related to fossil fuels in a bit, because they also affect our planet in other ways. But in terms of getting at energy, we need alternative solutions. And wind and solar are great examples. But as this fantastic question brings up, the sun doesn't always shine, the wind doesn't always blow. And this is one of the big challenges facing scientists like myself and like so many others all over the world. How are we going to make sure that we never run out of that energy so that we have it at nighttime, for example? So lots of people are working on energy storage. This is actually an area I'm working on, so I'll talk a bit more about my own research later on. But the two main ways of storing energy are in batteries, which I'm sure you've all heard, you all know about batteries. It might be in your remote control, or in your computer has a battery in it. But you can get batteries on really big scales that can be used to store electricity for towns maybe. And another option is something called solar fuels, which is what I work on, and that's a way of specifically storing solar energy in chemical bonds. So you can make a chemical out of the sun's energy essentially, and that essentially holds the solar energy that you can to then use at a later date. But yeah, it's a big problem, and it's something that a lot of clever people are working on.
Wow, that seems like a huge problem. Just trying to figure out the mystery of capturing the sun's energy. But I do want to mention. So you did mention climate change. Maybe just for our viewers at home, what do you mean by that? What is climate change?
Sure. So climate as a general term means the sort of expected weather conditions in a particular region. So the expected amount of rain you might get in a year, or the sort of average temperature in different seasons. And when we have climate change, that means that those longer term weather patterns are changing permanently. So it doesn't mean that like one day it's rainier than the next, but it means that over time you get a lot more rain, or over time you start to get more frequent droughts. Those sorts of things are climate change. And this is brought on by something called global warming. So we've got a few slides that we can show to sort of help explain this.
Wow, it's amazing.
So this is the Earth in the middle, and it's got this grey ring around it, and that's here to represent something called the atmosphere. And this is a load of gases that surround our planet. And this is really, really important for making it possible for not just humans, but all the plants, the animals to live on Earth. So what happens is the energy from the sun, it hits the Earth's surface, and some of it goes straight back out to space, but some of it is trapped inside this atmosphere. So that's kind of shown by the red arrow here. It stays inside the atmosphere, and this keeps the surface of Earth warm, and warm enough for life, which is great. It's a really important process. We wouldn't be here without it. But the problem is that humans have been burning the fossil fuels that we spoke about a bit earlier on. And when you burn fossil fuels, these release more greenhouse gases, a key one being carbon dioxide, which a lot of you might have heard of. There are other ones, for example, methane is another one as well. So these are released into the atmosphere from cars, but also factories, like sort of most things that humans do have some sort of fossil fuel usage. And as these gases go into the atmosphere, they basically make it thicker, really. And so less of the sun's energy can get back out to space, and more of it stays inside the atmosphere. And this leads to global warming. So the average temperature of the Earth is increasing, and this is what's causing climate change.
Wow, it seems like a huge problem. And so how are researchers helping global warming help fix this?
So there's loads of people doing really great things all over the world, and so many different aspects of tackling this challenge, because it's a really sort of wide-reaching problem, and it's not just chemistry, it's an engineering problem, it's also a sort of social problem, it involves politics as well. But in chemistry, and the type of chemistry that I do, I'm looking at ways of storing solar energy to help with the renewable energy, not the problem, the solution. So well, I think we also have some slides to show this, but basically water is made up of hydrogen and oxygen. Now, there's loads of water on planet Earth, it's everywhere, so it's a great resource that we could potentially use. So it's possible to use the sun's energy to split water into hydrogen and oxygen separately, rather than having them together in the form of water. And this is really useful because hydrogen can be used as a fuel. So the research I'm doing is on materials that can do this splitting process. And once you have the hydrogen from the water, this can be used in many ways, but a key one is a fuel cell, as shown in this slide. So a fuel cell, you put your hydrogen back in, oxygen, there's loads of oxygen already in our atmosphere, so it's not a problem to get that. Mm-hmm. And you put them back into the fuel cell, and you can make electricity straight from those chemicals. And the only excess product that you make, so the only other thing that's made apart from electricity, is water, because you're just combining those two back together. And this is really key because, as we said before, fossil fuels, when you use them, release greenhouse gases, but water is harmless. It's also not a pollutant, so it's not bad for human health either. So hydrogen's not just a green energy source. It's not just renewable if we're getting it from solar energy. It's also clean, which means it doesn't pollute our planet. And the electricity can be used, so you can have fuel cells in cars, as shown in this diagram, to power a car. The electricity can be used to sort of, for normal electrical devices. You can also use the hydrogen directly. So for example, in heating homes instead of the gases that are currently used. So it's quite a versatile fuel. And so, yeah, so that's what I'm working on.
Wow. So really essentially you're just trying to find ways of capturing the rays from the sun, the energy from the sun, and just condensing it and using it to power our homes, schools, and cars, right?
Yeah, that's exactly right. And the key thing here is that obviously, as you mentioned before, we have solar cells already, solar panels, which can on top of houses, and they are brilliant at powering homes when it's sunny. And solar fuels is then about storing the solar energy so then we can use it when it's cloudy or at nighttime. So it's sort of a combination of the two that will be really, really helpful in going forward. But obviously the next big challenge is developing something that can be scaled up and used on a large scale.
Yeah, that was going to be my next question. Like, how are we going to do this on such a large scale? The world is so big.
Yeah, so this is a really important thing to think about when you're researching a problem like this, because if you think about baking a cake, for example, if you're baking a cake at home in your kitchen, you have like a mixing bowl, you can make a cake quite easily. One mixing bowl, one tin, one oven, that's fine. But if you wanted to make a cake for, I don't know, 100 people or 1,000 people, you can't just use the same thing because your bowl would get too big. How would you mix it? And how big an oven would you need to fit all those cakes in? So you can't use the same process, just more, to reach everyone. You need to think carefully about how you can reach everyone. So whether that's thinking about how things work in a factory, so that you can do things on like a conveyor belt, for example. So as things go along, you add your butter, then you add your sugar, and you can add things as you go along. And the same thing applies to when we're thinking about energy solutions. So when I'm doing research in the lab, I might be making something that's, smaller than my hand, but that's not going to power a town. So I need to be thinking about, am I making it in a way that can be used in a factory later on, or can be used to power towns and cities and even countries?
Wow. So yeah, it's really just about, finding ways of putting that on a larger scale because it's such a global problem, right? Like it has to be done on a wide scale. But although it is a big problem, is there anything that we can do at home? So just to our viewers, make sure you put in the chat, what do you think you can do at home to save energy? We would love to see that. But before we look at those, what do you think, Louise? What is it that you can do at home? What are you doing at home?
Sure. So obviously the good thing about a global problem is that it has a global solution, which means that every single person on the planet can help make a difference, including all of you at home. So yeah, please let us know in the chat any ideas you might have. And in the meantime, I've just noticed as well, we've had a question in from Kayla.
Yeah.
Who wants to know, are there certain types of chemical compounds that are considered more green than others? So that's a really good question. Yes is the simple answer. When you're thinking about how green something is, you have to think about what we call its life cycle. So this means where it comes from originally, how you make it into what it is in the middle, how you use it, and what happens afterwards when you finished using it. So lots of our chemicals, sort of everyday chemicals, for example, plastics, lots of them come from fossil fuels. So at the moment, so the sort of byproducts, the things that are left behind once you've got out the things we use for our energy. So digging those up, obviously from the ground, currently comes with implications for our planet, as we've spoken about before, climate change. So that's something to think about, where things come from. So you can think about reusing things in the life cycle. So can you make something out of the waste from a different process? So that a chemical like that would be more green because you're not using brand new sort of source materials. And things that can be reused or recycled or repurposed are greener than others as well. And something that some of you might have heard of as well is this term like biodegradability. So some plastics is another good example here. So lots of our plastic, well, most of the plastic in the world doesn't biodegrade. Oh, my camera's decided to do something funny. Hopefully that'll come back in. But it just, it fills up our oceans, it fills up rivers and things like that, and that's a real problem. But there are plastics that exist that can be broken down by little like bacteria and little organisms in the soil or in the bottom of oceans, and those are more green as well. So yeah, that's a great question, and the answer is that simply yes, and more. The longer answer is it's complicated.
That's an amazing question. And thank you so much, Kayla, for putting that in the chat. And make sure everyone at home, if you guys have any questions, make sure you put it in the chat and we'll take a look and try to answer them later when we do a Q&A. But I'm just thinking back to that renewable energy kind of thought process. And I guess something that I think we could do at home is maybe, turn off the lights or turn off any appliances you're not using, which is a really great idea. Don't you think so?
Yeah, that's a really great suggestion. So any energy, we don't want to be using energy, wasting energy when we're not using it. So turning off lights, turning off any computers or the television or anything like that when you're not using them. Those are great things to do. Another example would be to make sure you're recycling things, because if we reuse resources to make new things, that means we don't have to use energy to get more raw materials, for example, and that can save energy as well as things. So yeah, lots of things we can do. And another one as well is to do with our diet. So think about where our food comes from. So for example, meat has quite a big sort of carbon footprint, which means that there's a lot of greenhouse gases emitted from the meat industry. So perhaps thinking about replacing one of your meat meals a week with a vegetarian meal could be a good option, or using seasonal vegetables that have come from somewhere local rather than ones that have been flown a long distance around the world is another thing that can help as well.
Right, because then when you bring things in, obviously there's a lot of carbon dioxide and greenhouse gases that are emitted when you kind of transport things in from a long ways away. So those are amazing. I guess I just want to know are there ways that we can help outside of our home? I mean, I know that one of the biggest sources of carbon dioxide is transport, just getting people to go from one place to another, or food in that matter. So maybe in the chat, you guys can let us know what are some different types of transport that may kind of have a carbon footprint. I guess from the top of my head, it would be like cars and airplanes. But yeah, put it in the chat. We want to hear from you guys.
Yes, let us know your thoughts.
Yeah, I think I've definitely been on a flight or maybe a long car ride. That's definitely, I can imagine, a greenhouse gas emitter.
Yeah, what about other sort of public transport as well? Are there examples anyone can think of that they might have got instead of private vehicles as well?
Yeah, I guess it would be better to take public transport as often as possible, right? Because then you have more people on a bus, let's say, and there's less people in individual cars probably.
Yeah, that's a really good point. So public transport generally is much better for the planet, because if you think about it, you're sort of splitting up the say it's powered by petrol. You're dividing the petrol used by many more people. So if they all got their own individual cars, we'd be burning a lot more fossil fuels and therefore releasing many more greenhouse gases than if we were going together on a bus or on a train. There's some clues for you.
Yeah, I guess honestly that's something that I can start doing more, is making sure that I get on some public transportation. Okay, so I want to open it up. Maybe we don't have to talk about different types of transport, but we do really want to hear your questions. So just make sure you put them in the chat, and we can hopefully, Louise, she most probably can answer them if you guys have any questions. I guess to start us off, I have a question. Louise, what are fossil fuels made of? We keep mentioning the word fossil fuels, but I don't actually know what they're made of.
Sure. So they're actually a mixture of all sorts of things. And small organisms is what they are, small things. And by organisms, I mean sort of any sort of plants and animals, but it's not animals like we think of now. I'm not talking about big things like dogs or cows or anything like that. They're smaller, sort of more like bacteria or germs, that you might, some of you might have heard of those sorts of things, and they decay over time and get compressed, because they're found, like lots of oil is found, for example, deep at the bottom of the ocean. So lots of that pressure over time means that they sort of decay in a way that makes them really energy rich. And as I said, that process takes millions of years. But the energy in them originally essentially comes from the sun. So it's a bit like some of you might have heard of biomass, which is a renewable energy source. And that's because plants store the sun's energy inside them. And we can burn plants, some of these crops, to get energy back out. And obviously we can grow crops again reasonably quickly. So that's a sort of a renewable option. But fossil fuels, originally, they also stored the sun's energy inside of them. But because of the way they were formed over millions of years, that's not renewable because we use them so much faster than they can be made.
Wow. Honestly, having this conversation, I don't think I realized energy is everywhere. It's
Yeah.
That's crazy. Okay, so feel free to add questions into the chat. We will always answer them if we can get to them at the end. But I guess now we're going to start the quiz, if everyone's ready. So just to give a lowdown on the quiz, we've got 5 questions. They're all 1 point each. Talk amongst yourselves at home, but please don't put the answers in the chat. We want everyone to kind of answer on their own. And to make things easier, maybe grab a pen and paper so you can write them down. And we'll be going through all of the answers at the end. So we'll go through the questions first, and then we'll go back and we'll answer them at the end. And sadly, there is no prize, but there is the pride of knowing that you have gotten an answer correct. So that's important. Okay, so let's start with the first question if everyone's ready. Okay, so I'll read the first one out. So Louise is a researcher. What does it mean to be a researcher? So question A is it's being told the answers. B, it's finding new things by doing experiments. And C, it's looking stuff up on Wikipedia. Okay, so make sure you write down your answer. I'll go over the question one more time. Louise is a researcher. What does it mean to be a researcher? Is it being told the answers? Is it finding new things by doing experiments? Or is it C, it's looking up stuff on Wikipedia? All right, so write down your answer and we'll go on to the next question.
Okay, so question 2. Which of these is the source of almost all of our energy on Earth? So is it A, the sun, B, the moon, or C, Mars? So I'll just repeat that question. Which of these is the source of almost all our energy on Earth? A, the sun, B, the moon, or C, Mars?
This is exciting. Okay, if everyone's ready for the next question. Which of these is not a greenhouse gas? Is it A, methane, B, oxygen, or C, carbon dioxide? And I'll go over it again one more time. Which of these is not a greenhouse gas? A, methane, B, oxygen, or C, carbon dioxide? Let's see.
Okay, so question 4, what is global warming? Is it A, when the Earth heats up naturally? B, it's caused when we release extra gases like carbon dioxide and this traps in heat? Or C, it's what we call summertime. So that's what is global warming? A, when the Earth heats up naturally. B, it's caused when we release extra gases like carbon dioxide and this traps in heat. Or C, it's what we call summertime.
All right, last question. Which of these is a direct consequence of climate change? A, sea level rise. B, new animals are discovered. or C, we get closer to the sun? And I'll say it one more time. Which of these is a direct consequence of climate change? A, sea level rise, B, new animals are discovered, or C, we get closer to the sun. All right, that's it. Hopefully everyone's written down their answers. And if you're watching this back later on, pause here if you need some time. But now we're going to go on to the answers. So let's see. I'll go through them, and then maybe Louise, you can tell us what the answer is and maybe give us a little bit of information. So just back to question 1. Louise is a researcher. What does it mean to be a researcher?
So the answer to this one is B. Now, I apologise, the wording here is slightly different to the question you had before, but both are correct. So it is finding out new things by doing experiments, which is what I do. But this sentence here, carrying out an investigation to discover new things, is a sort of broader explanation, because some people do research that doesn't involve experiments. But the key thing is that you're looking at something new. And I mean, people who don't do experiments, it might involve doing things like developing a new piece of computer code, or reading some important literature and making new connections between them. So there's all sorts of different types of researching. And as I've said, the type I do is experiments.
Cool. Okay, question 2. So remember, each answer is 1 point. So question 2, which of these is the source of almost all our energy on Earth? Louise, what's the answer?
So the answer to this one is the sun. And the reason is that, as I said before, the sun is the original source of the energy in things like fossil fuels and biomass. It's also obviously the source of solar energy. It's actually the sun that causes the wind patterns on Earth. So the sun is actually the original source of wind energy. So it really, really is the source of most of our energy on Earth. But if you put the moon, you weren't entirely wrong, because the moon is really important for our tides. So because the moon is quite close to the Earth, it has gravity. Lots of you have heard of gravity, I'm sure. It's the force that stops us from just floating around space. It keeps our feet on the Earth. And the moon also has gravity. And as the gravity of the moon pulls oceans and seas towards it slightly, and this causes our tides. And there's a type of renewable energy called tidal energy. So that is from the moon, but pretty much everything else is from the sun.
Oh, I see. Some extra information. Okay, so remember, 1 point. And then question 3. Which of these is not a greenhouse gas?
So the answer here is B, oxygen. So I'm sure most of you have heard of oxygen. It's the gas that we breathe in, that keeps us going. But methane and carbon dioxide are both greenhouse gases. Carbon dioxide is probably the main one you've heard of, but we do also release some methane, and we don't talk about it as much because we release less of it, but it is important because it's actually a much more powerful greenhouse gas than carbon dioxide. So the same amount of methane has a bigger impact on the greenhouse effect than the same amount of carbon dioxide.
Wow. That's amazing. Or I guess not amazing. I guess that's a bad thing. Okay, question 4. What is global warming?
So the answer to this one is B. It's caused when we release extra gases like carbon dioxide and methane, and this traps in heat. So this is coming back really to what we were talking about earlier, and obviously linked to the next question, to the previous question. So yeah, I think we're all experts on this by now.
Yeah, I think so. I think you did a good job of explaining it, which is pretty cool.
Thank you.
Okay, last question. Final count, final chance to get points. Which of these is a direct consequence of climate change?
So the answer to this one is A, sea levels rise. So as the global temperature is increasing, this sort of kind of makes sense, is causing ice to melt. So when I say ice, I mean in the ice sheets in the poles, so the Arctic and the Antarctic, and also glaciers up mountains, they're also melting. And as they melt, this is obviously extra water. And whether they're ice sheets or mountains, that water eventually finds its way into the seas or the oceans. So we're adding extra water to the oceans. And another thing as well is that as water gets warmer, it actually gets bigger, it expands. And these just a little bit, but this adds up over, it's a whole planet with a lot of water. So this causes the sea level to rise. And this is a particular problem for sort of low-lying island nations and also coastal regions, because they're most vulnerable to these changes in sea level, and they can cause increased flooding. So there is, a direct link between this process that's happening up in the atmosphere and actually impacts on everyday lives for people on the planet.
Wow. I'm honestly just thinking about it and hearing you talk, I think I'm starting to realize how big of an issue this is and how, multiple things are coming into play, right? Which is crazy. And then you have the work that you guys are doing, which is amazing, trying to tackle such a big issue.
Yeah, I think that's really key, because sometimes it can be maybe a bit scary to think about such a big problem, but we have so much amazing technology and organizations and people working on this problem, and we have the solutions, the science. We already know the science that can solve these problems, and so much of it's being done already. So as long as people keep doing what they can as individuals, and also anyone who, for example, is interested in science, who might want to help out from the science perspective, or people who are interested in helping people who are affected by flooding, or people who want to be in charge and help make decisions that can help steer us in the right direction. There are lots of ways that many people can help. So there's many reasons to be hopeful.
Yeah. Oh my goodness. There's such a huge amount of effort going on, which is amazing. So just so everyone is on the same page, we really want to hear about how you did on the quiz. And if you're watching at home later, I'm sure you can maybe put it in the comment section if that's there or something. I think we did have someone that got in touch about how they did. Wow. Kitty at home says she got all the questions correct, which is amazing.
Wow.
Well
done.
So smart and clearly listening. So that's really amazing. I'm thinking about it, and if I were to do it, I think I were to get all the questions right. And I think Louise would get 100% correct, right?
Well, I might have cheated though, because I did write the questions.
Yeah, so put your scores in the chat. But I hope everyone enjoyed that section of the webinar. That's really amazing. I guess now it would be time to kind of talk about our final comments, and just kind of wrap up what we've talked about today. I think we have a question that came in. A question from San said, was the floods in Europe linked to climate change? That's a really interesting question. What do you think, Louise?
It is a great question, and I will caveat this by saying I'm not an expert in flooding. It's really complicated sort of geography. So there are other people who I'm sure can answer this question better than me. But the simple answer is yes. So when you're looking at things like it, so it's not just flooding. There's other extreme weather events as well. So for example, there's been a recent sort of increase in wildfires. And flooding is another example, droughts also an example. And what lots of very clever people have done is they can basically model how likely a phenomenon like flooding is to happen in a certain region without climate change. And then they can see, given global temperature increase and other climate change events, how has the likelihood of that changed. And I don't know the numbers, but I think they found that the floods in Europe were significantly more likely because of climate change, and so they can be linked to climate change. But it's an interesting question, because it's not a straight cause and effect. Because the planet's a very complicated system. But yes, those floods were made more likely because of climate change.
Yeah, I think just because it's such a huge issue, maybe some things like that may be difficult to link everything directly to something, because it's probably like a web, right? There's a lot of things happening at all times. But that's a great question.
Yeah, sorry to speak over you, but just saying a web is a really great way of thinking about it. It's
Oh,
none of these things exist on their own. They all exist within the world next to all these other problems, and many of them, affect each other really.
oh my goodness. Yeah. And a web can easily get tangled, obviously.
Yes.
Okay, so yeah, if anyone has any last minute questions, feel free to put them in. I guess my last question for the audience and for everyone else is, now that we've had this conversation, what's one thing that we all can do to kind of protect our planet? It's a huge issue. So yeah, let us know in the chat. Let us know what you think. I guess if I were to think about it, the one that really stood out for me was turning off the lights. I think it's maybe something that I don't think about all the time, but I can very easily just turn off a light, and I know that that's going to help us save energy and make a difference in the long run. But what do you think, Louise?
Yeah, so I think maybe something I need to think about is how I'm getting into work. So at the moment, I take public transport, which is obviously like a very good option, but I don't live that far away. So maybe I should start cycling more. So maybe I'll set myself a challenge of cycling in maybe 1 day a week extra to start with and see how I get on. Obviously, important to wear your helmet, which I will be doing. But yeah, that's something that I think I might change.
Yeah, that's amazing. I can't tell you how many times I've left my house without my helmet and then had to go back because it's super important to wear it. So
Yeah, it's worth going back.
going back, exactly. So yeah, if anyone wants to put any of their ideas in the chat, we'll take a look at them. But just to stay on schedule, I think Louise wants to introduce an activity that everyone can do at home. So we can't get our researchers to do all the hard work all the time. And maybe you guys at home can put your heads together and come up with some ideas. So I think we're going to be designing some cars. But Louise, do you want to explain the challenge maybe?
Sure. So this is about sort of bringing together everything we've talked about today, from the different options for renewable energy and also the changes we need to make. And one of the big areas that needs to be improved is transport. I'm sure lots of you have heard of electric cars, but it's not just about cars. What about planes? What about boats? What about helicopters? There's all sorts of transport that we need to make green, basically. So we've developed this worksheet for you, which will be available. We'll send a link to the online version in the chat later, and I think it'll be sent to you after the webinar has ended as well. But there's basically this worksheet which talks you through a bit of the science we've discussed today, to sort of remind you of the key points. And your challenge is to design a new green energy vehicle for the future, and preferably a clean energy one. So we don't want to be polluting our planet. So there's a little flowchart diagram of things to think about. So the first decision is, what vehicle are you going to make? There's so many options. It could be a vehicle that doesn't exist yet. You can mix some things together. Be as creative as possible. This is an important point. It's not just about like the science solutions. Science is creative. You've got to think outside the box. Be as wild and as imaginative as you can think. So once you've chosen your vehicle, pick your fuel. So maybe it's solar powered, maybe you've somehow stuck some big wind turbines on it or something. Maybe it's a combination of them. Obviously style is important. You want it to stand out, or do you want it to blend in? Maybe it's camouflage, who knows? Do you have any other sort of special design features in your vehicle? Does it do something extra other than just transport people? And then think about, once you've sort of come up with an idea, maybe you've drawn a picture of what you're going to make, you could actually make it. So think about what you can make it from. And I would really recommend here thinking about going through your recycling box at home, because we all know it's really important to recycle to help protect our planet. So if you've got like an old cereal box or an old juice carton or something, and then get creative, and let's see what you can come up with. I have a Blue Peter moment of here's one I prepared earlier. So I had to go at this myself, and this is my plane. So this is like a juice bottle down the middle. I think that's the cereal box wings. My engines are made of a yogurt drink carton. So do be as creative as you can. Oh, my camera's gone again.
No.
So my plane was powered by biofuels. So I mentioned that earlier. That's made of plants, and those power the jet engines. But my wings are covered in solar panels for the internal electronics of the plane. And then I was like, what else can my plane do? So I put green plants on top of my plane to help absorb some extra carbon dioxide from the atmosphere. And I've also got a water tank at the back to then water plants below. So I thought it could help make the world a bit more green. So
Oh my
yeah,
goodness.
I'm really
This is
excited to see what you guys can come up with. I'm sure it'll be much more exciting than mine.
honestly, this is my favorite part of science is people getting creative. I think there's such a space in science for creativity, and I think that's really cool. So just to remember, you can download the activity, the PDF, in the link in the chat. It should be there at some point. And I guess just to wrap up, I want to say thank you to everyone. This was so amazing, and thank you so much for Louise for coming in and sharing your knowledge. Yeah, so the recording, if you're watching this later, the recording is on YouTube. And then I guess thinking about what we learned, we talked about renewable energy, talked about green chemistry, and then we kind of went into Louise's work, a little bit about, on a larger scale, why it's important, why, it's important for climate change, global warming. Yeah. So also the last thing is that there will be a link in the chat for a quick survey, and it would mean so much to us if you could take 5 minutes and fill it out. That would be really amazing. So that should be posting soon. And keep an eye out for future, family workshops like this with the Great Exhibition Road Festival. I think there's one coming up some point in December, and it's going to be kind of greeting card making, which is really festive and great for the holiday season. But yeah, other than that, thank you so much for joining. And again, thank you, Louise. And yeah, hopefully we'll see everyone soon. But bye.
Thanks everyone at home, and thank you, Sophia, as well.
Yeah, no, of course. See you guys.